Namaskar, Nileshok, with another session of Dr. No Shorts. This would be Dr. No Shorts number 9. We continue to discuss empirical, precise, scientific, logical, oceanography evidence from around the world that corroborates, that validates, that proves in ordinary language the flooding and destruction of Krishna's Dwarka in the year 5525 BCE. So that's 5525 plus 2022. Add those numbers, those many years ago. This would be part 9. In this part, we are going to look at another set of impressive evidence for flooding and destruction of Krishna's Dwarka in 5525 BCE, this time from the coast of Western Australia. Now, if you recall, we have already looked at impressive evidence from the northwest corner of Australia, the Great Barrier Reef, where there was a sudden sea level rise in 5525 BCE. And after that, essentially, it remained flat, not only flat, but after 4000 BC or after some time, it actually started going down to the current sea levels in that region. This time, we are going to go to the western, or rather the northwest corner of Australia. The place is called Barrow Island. Okay, so just so that you can ground yourself geographically speaking. Okay, the Desha Kala Patra. So this is a Desha. The Kala, of course, 5525 BCE. And the context is flooding and destruction of Krishna's Dwarka 36 years after the Mahabharata war, which we have shown with exhaustive astronomy evidence from the Mahabharata text, 300 plus specific descriptions, bringing together in an empirical fashion, objectively testing each one of them in a scientific fashion, logical fashion, solving the big jigsaw puzzle, solving the crossword puzzle, all of it pointing to only one year, 5561 BCE, and no other year, no matter who tells you what. All right, the evidence is that impressive. But that's based on the celestial markers that were noted down by Bhagwan Vyasadeva at the time of the Mahabharata war and embedded in the Mahabharata text when he composed the Mahabharata of 100,000 verse long, about 18 years after the Mahabharata war. And it took him 3 years to compose it. All right. Now, this evidence is from the terrestrial, okay, from the ground, and from around the world. So let's look at it. So Barrows Island in the northwest corner of Australia, and let's go there. This is based on a research paper, all that peer-reviewed and all that good stuff, especially for those people who are truly stuck in the rut of academia, the dogma of academia. Again, I'll repeat, there is a good logic. Okay, the very concept of peer-reviewed papers is beautiful. I mean, it's a right concept. But with all the dogma, instead of science, people looking at a consensus of the so-called experts. And how do we decide the experts? Based on degree certificates, that are just given in Marathi. I would say that are given like a kirapat. Those people who understand Marathi would know what that means. Kirapat is a sweet prasad made out of dry coconut sugar and some spices, I suppose. And it's distributed readily. That's what is happening. So that's my rant and vent on the peer-reviewed papers, peer-reviewed journals. Now, People ask me, why do I not publish in peer-reviewed journals? Again, the point is, if I get benefited from it, like if I'm in academia, mainstream academia, in the sense I have to crank up many papers, I can assure you, and somebody may want to offer me a position in academia, I will crank in terms of the average number of peer-reviewed papers per faculty. Okay, I can assure you, I would be in any disciplines in the world, any discipline in academia, I would be in the 95th percentile. I'll be in the top 5 percentile. I know the art of cranking peer-reviewed papers. In my current role, it does not benefit me. It only would waste my time. Okay, and the artificial barriers that are created are I just know the inner working. Many people, sometime when I meet them at conference, and they'll say, hey, if you want to publish the paper, let me know. I can get it done, when I'm nice to them and so on. I said, no, I don't need to publish a paper. In fact, I would love to send a paper and get the rejection and just, keep the evidence of that rejection. Okay, because original work doesn't get quickly accepted by the dogmatic minds. Anyways, I had enough of that rant and a vent, so now vent off. Let's get to this evidence. So this is some kind of peer-reviewed paper. Okay, so those people who otherwise would have a problem, they shouldn't have a problem understanding this data. You hope so, right? No guarantees whatsoever. Okay, what is it showing? This is quickly looking at the sea level rise. These are mean sea levels at that location. Think of it, it's very important. The sea levels change by locations because of the land subsidence. Okay, although because all the water bodies, all the oceans around the world are in a way connected to each other, so more or less the water level should be the same. But with respect to the local landscape, it would not look the same, it would not appear the same. Therefore, it's very important to remember this. Notice this is a very beautiful chart, because notice that blue line in the middle, and then there are two lines on the sides. What are those? Those are, like, think of them as a confidence limits, okay, or statistical error limits, something like that. Okay, so the blue line is the mean estimate, and the actual number, again, that's the estimate too, appears to be, or with certain level of statistical confidence, would be between those two greener levels at any point in time that is shown on the x-axis. Quickly, I want to show you 2 points from this graph, okay, or today. One is, notice now the x-axis is years before present, BP. So if you go all the way to the right side, we are going all the way back to 140,000 years, okay? So just like we saw in the last 20,000 years, like the last glacial maximum, think of the glacial maximum before the last glacial maximum, okay? Before the recent glacial maximum was where? Was about 140,000 years ago, at least based on this specific data. Okay, so that's what it was here. And then there was this sudden sea level rise, just like what we have seen in the last 20,000 years, happening between, say, 140,000 years to 130,000 years. Now we are fast forward the time, and I'll show you some markers. Okay, don't want to take too much time on this, but if you are familiar with the work of Rupa Bhattiji with respect to Maitrayani Upanishad and King Brihadrath of Ikshvaku dynasty, and he referring to oceans becoming dry, and the pole stars moving, and many natural calamities happening in the other direction. Actually, the oceans are going down, and that was in this region about 34,500 years ago, where my arrow is. Okay, this is the area when he's referring to. So Maitrayani Upanishad apparently captures it, but we also have a parallel validating, corroborating evidence from Surya Siddhanta with respect to star Agastya. Okay, that's enough for right now for that discussion. Let's fast forward to the time of Ramayana, 14,000 years ago, and notice a significant jump. Okay, compare this with catastrophic rise event number 1 that you would have seen in the Western days. If you don't recall what I'm referring to, go back into this Dr. No short series and watch the episode on the data for flooding and destruction of Krishna's Dwarka in 5525 BCE from Caribbean West Indies. Okay, and you'll know what I mean. CRE1, catastrophic rise event. How consistent is this data around the world? Now, the next thing I'm going to do is look at this top rectangle here, highlighted into sort of a light orange brown color, whatever you want to call this. I'm going to expand this, okay, which is what, last 10,000 years, and show what happened in 5525 BCE. Okay, it comes from that same research paper. So just taking that portion, this last rectangle, last 10,000 years, recent 10,000 years, Holocene, that's also called Holocene, which means recent past. Okay, that's what it means. All right, so this is the 10,000 years of data. Again, we have to go from right to the left. And sudden peak. So this is that peak here that you are seeing, okay, expanded. And notice when they have shown it in the shorter version, like expanded version rather, they have not taken this peak into account, okay? So they have made it like a sort of an average curve going up. Just be aware of this. So suddenly you see like some kind of like going down, and you know, this is like somebody. I used to teach Lean Six Sigma. I still teach Lean Six Sigma. I do consulting in Lean Six Sigma. And when people are analyzing the data and when they want my help and they say, well, look here, it's going a little bit down and why it could be? Well, sometimes it means a significant thing. Other times it does not mean a damn thing, okay? So you have to have that experience. Some of the things you only get through experience. It will not come from teacher teaching you. It will not come from listening to audios. It will not come from reading the books. It will not come from your degrees. It will come from your experience in the field. Sometimes, like if you try to read this, that is like you are just like micromanaging. This is like micro analyzing. So I'm just mentioning it. That particular rectangle where there is a blip here, it's not shown in here. Now, if somebody wants to study it more, they can, but it's not relevant in this case. So what do we see? If we looked at this data from the northwest corner of Australia and map it against the 5525 BC, a sudden sea level rise, okay, of how much? 20 plus meters. Look at it on the y-axis, okay? So this is minus 20, this is minus 10, this is 0. This is where it came, like 0 today. But look what happened. Actually, there was a sudden pulse, okay, going at this 5525 BCE. But guess what? Now, I am saying 5525 BCE because that's what we know the year for the flooding and destruction of Krishna's Dwarka. We are using this as a matching, validating, corroborating evidence. Now, when this rising sea level flooded and destroyed Krishna's Dwarka, it didn't say, oh, okay, my job is done. I'm stopping here. No. Actually, the water levels continue to rise. And notice this, because this is what we have seen before, but just like the previous one we looked at, which is the east coast of India, Tamil Nadu, the water going, not only destroying the port number 3 at Pumpuhar, but going inside, ingressing for 15 miles, going further high to up to 10 meters. That is what the altitude of Mayuram is. And staying there for additional next 2,000 years before started receding. Notice what is happening here. Almost exactly the same thing. The water level continued to rise, went up. It didn't stop. You know, it didn't stop after flooding and destroying Krishna's Dwarka. It went up, possibly how much? Like, let's see, like 3 meters. Remember that number, 3 meters. Okay. When we look at the Krishna's Dwarka, we are going to have a deja vu. 3 meters above than how far it reached in 5525 BCE. And then it stayed there for a while. And when it is slow, it started slowly receding. But guess what? In this data, after it reached that peak, maybe around what time would that be? Yeah, we can go to, this is 7,000, so 6,000. Okay, BC, 6,000, 7,000. Yeah, so that's 6,000. So that's like 4,000 BC. See, remember, that's a peak again. We have seen this consistently. so far. And after that, it started actually receding. It continued to go down. So 4000 BC to now, like last 6000 years, water sea levels are continuously going down. They are not going up. Of course, they may have their local ups and downs, okay? And tsunami, sometimes tsunami will come, and in a temporary fashion, for a temporary time, a certain time, the water may go up, just like the 2004 tsunami. But then eventually it's going to recede and get back to the normal level. But these mean sea levels are actually going down since 4000 BC, last 6000 years, and coming down to the today's level. Okay, what we consider mean sea level today. That's it. Okay, remember this. This is very important for understanding flooding and destruction of Krishna's Dwarka in 5525 BC. But even more important, it is critical for understanding and falsifying any other claim for flooding and destruction of Krishna's Dwarka other than 5525 BC. And of course, therefore, any other claim for the year of Mahabharata war that is different than 5561 BCE. All right. Okay, let's do a quick summary. Where did we begin? 9 different scientific parameters for the Black Sea formation, 5525 BC in Turkey. 7 different locations, 20 feet plus sea level rise in the Caribbean. Great Barrier Reef, a significant sea pulse in 5525 BC, followed by maintenance of that water level for a long time and finally receding to our current times. We looked at Dogger Bank, sudden disappearance of a Dogger Bank in 5525 BC. We looked at a significant land subsidence and what it can do, and if you are not careful, how it can actually lead to a wrong conclusion, misleading conclusion, with respect to the sea levels if there is a significant land subsidence. And we looked at the causes of land subsidence, especially in Maine. Now, that has happened in all different places too, but especially in Maine because of the immense glaciers that were there, okay, the Laurentine glaciers and other glaciers in that region, the North America. Okay, and when they started melting, the land started popping up, and it gives a very different interpretation for the sea levels if you are not careful and if you do not make corrections for this. Then we looked at Red River in the Kingdom of Champa, now what we call Vietnam, okay, the Gulf of Tonkin, the South China Sea, which used to be called the Champa Sea. And again, tremendous evidence, beautiful evidence, 7,500 years ago, 5525 BCE, followed by what? Followed by a flat line, no more addition, and actually the water coming down to today's level, very consistent. Then we looked at the Pumpuhar, okay, that also, this evidence also showed us tremendous evidence for deep antiquity of Indian navigation and therefore Indian civilization going back to 20,000 plus years. But it gives you a very specific information that is useful when we get to Ramayana discussion. Again, read my books, guys. Don't wait for the videos, okay? Pick a copies of my Mahabharata book, Ramayana book, Bhishma Nirvana book. I am in the process of writing more, but one-man show, okay? Time is limited, only 24 hours. Do look at this evidence. It's very consistent for the antiquity of Indian civilization. Very corroborative, supportive, validating evidence for Ramayana timing, and not to miss the flooding and destruction of Krishna's Dwarka in 5525 BC, gushing waters, ingressing waters coming to Mayuram 15 miles inside the land, staying there for the next 2000 plus years and receding only after that over the next 6,000 years down to our times, okay? And today we looked at the evidence from a Barrows Island. Again, what do we see? Beautiful pulse just after the Ramayana times, and it only remains our guess what that pulse of another 20 plus meters there. I'm not confusing that with the Krishna's Dwarka time pulse in 5525 BC, but the one that I showed before, okay, I'll not go back, that it just remains to be found out, like what that sudden sea level rise did to Ravana's Lanka, okay, which was on the equator along the 0 longitude. All right. But even for the Mahabharata time, 5525 BCE, a sudden sea level rise of 20 plus meters. After that 5525 BCE, the water continued to go up for additional 3 meters or so. Remember that number when we get to Dwarka evidence. But so it reached that peak by 4000 BC approximately. And after that, the sea levels are actually coming down as seen from the Barrows Island to what we consider today's mean sea level. So coming down by about average of 3 meters. Okay, quick summary. So empirical archaeology and oceanography evidence for flooding and destruction of Krishna's Dwarka in 5525 BCE. We are seeing it everywhere from around the world. Okay, just a quick summary. I'll not read that because I just made a summary at the map. Black Sea Formation, different locations in West Indies, Dogger Bank, Maine, Vietnam, East Coast of India. Okay, the evidence is just piling up, guys. At some point, you have to say, and we will talk about that. At some point, the evidence is so strong, so precise, so accurate, so scientific, so empirical, so logical, that any additional evidence does not bring a quantum additional value. At some point, you'll start losing the value of additional evidence because the existing evidence is so impressive. Okay, and we'll talk about the role of such evidence in science, in validating the new theories, in falsifying old theories, and so on and so forth, falsifying other dogmatic claims, and so on. So there is a value. At some point, if I bring like additional 10 pieces of evidence, and it is there, guys. So anyone who feels enthusiastic should start reading papers on oceanography and delta formations and sedimentology and so on. They are there, okay? Oceanography, climatology, sedimentology, guys, sky's the limit, okay? The river valleys that are under the sea now, when they were formed, okay? And the dating of those and so on, a lot of information. A sudden sea level rise of 20 meters based on this data that we shared today, from the west coast of India, west coast of Australia, forgive me. And sea levels went up beyond 5525 BC. This is very important to understand. Went up approximately by up to 4000 BCE and then started receding, okay, after 4000 BCE from this data. But that is also true for the Pumpuhar data. And you are going to see how consistent the picture is from Great Barrier Reef or the data we are going to look at, the Dwarka, the Arabian Sea itself, and additional data that we're going to look at, okay? So very important, and that is important to decisively falsify, meaning it's been already falsified, but for those people who are late to get the news, okay, for the falsification of any other claim for the year of Mahabharata war and any other claim for the year for Krishna, the flooding and destruction of Krishna's Dwarka. All right, that's it. So I'll see you soon in another episode of Dr. No Shorts. Namaskar.